بسم الله الرحمن الرحيم.
Pipes and different head losses. So it is constant value. And if the length of the pipe, okay, if the length of the pipe is greater than 1,000 times of dia of the pipe, then minor losses become significantly lower. In that case, we will consider the friction loss. So here is the little bit limitation. Okay, if our pipe is too much large in length, okay, and we will not consider these minor losses, but we'll consider the major losses, that like friction losses. Here are the minor losses that can be categorized in the head loss due to contraction, entrance loss, head loss due to enlargement, mean sudden divergence. Okay, it may be convergence, it may be divergence, entrance loss, exit loss, head loss due to pipe fitting. We have discussed it earlier that it may be pipe fitting, maybe in T shape, bend shape, elbow. We also used simple words, elbow or T. So head loss due to bends and elbows. Here are first loss, that is head loss due to the contraction. When pipe is contracted, you can see this figure, that here is the pipe. Okay. Here is the pipe but in this pipe, the from when flow move from entrance to exit or from upstream to downstream, then the pipe is contracting. Okay, its dia is reducing. So this reduction of dia from larger to lower, then there will be head loss. It will generate the head loss. Here over you can see the energy gradient line and the hydraulic gradient line. So the difference between energy and hydraulic gradient is the velocity head. It means that hydraulic gradient line can be observed that this hydraulic gradient is reducing after reducing this dia, and similarly there is no impact on the energy gradient line, because when when dia is reducing, then definitely velocity and dia or area have inverse relation. So when reducing dia, uh, increasing, yeah, there is no difference. There is no impact of reducing this dia, because because energy gradient line depends upon the velocity, and in this section the velocity will increase. So head loss definitely will create, but a huge impact will be on hydraulic gradient line as compared to energy gradient line. And its formula for the sudden contraction is HM is equal to KCV square root 2G. Here is the C is representing the contraction. So KC is the coefficient of contraction. So its value will also be constant. Okay, so its value, if you have a problem, numerical problem, then you will given this constant or coefficient Kc. The next one is the gradual contraction. Here is the sudden contraction. Okay, here is the gradual contraction, in which we have studied about in the Venturi method, that is gradually contracted the pipe dia. Okay, so its formula is also same, that is Kc dash. Okay, it is also a contraction, but because it is gradual, so it is represented as Kc dash V square over 2G. Here Kc is representing the gradual gradual contraction of coefficient, and its value depends upon the d2 divided by d1. What is d2? D2 is the dia of the downstream pipe, and d1 is the dia of the first or upstream pipe. Okay, here alpha can also be play a vital role, because this alpha or this angle from these two walls can vary from situation to situation. So if this alpha can be play vital role, so you have to consider this alpha when, अगर हम इस फार्मूले को थोड़ा सा एक्सपैंड करके देखें तो इसमें अल्फा भी यूज होता है. So in this relation, alpha can play a very important role, but in expressionally mean के इस expression के अंदर अल्फा आपको नजर नहीं आ रहा, लेकिन जो अल्फा है ना वो ये जो फार्मूला है एक अल्फा के लिए कांस्टेंट है नहीं, मीन के जब हम इस फार्मूले को थोड़ा एक्सपेंड करेंगे, के सी जो हमारा कोएफिशिएंट ऑफ कंट्रैक्शन कांस्टेंट है, अगर हम इसको देखेंगे तो इसके अंदर अल्फा भी मौजूद है. So these are the entrance loss. HM is equal to KE is representing the entrance loss, entrance coefficient, uh, entrance coefficient. Okay. It means that जितने भी आपको ये losses नजर आ रहे हैं उनमें सिर्फ K की वैल्यू चेंज हो रही है, बाकी किसी की नहीं हो रही. क्यों? Because we are studying about the uh, minor losses which is due to the enlargement or head or entrance losses. अगर हम start में देखें यहाँ पे head loss due to contraction, it was sudden or it is gradual. Now we are studying about the entrance losses in which only K is changing, but not another. But if we will see in other slides or next slides, then we will observe that these quotient will also be changed. So HM is equal to KE is the entrance loss. It will also be different for different entrances because it vary. For example, if you see in first figure, then its value is 0.5, and if entrance is changing, that is entrance is a little bit inside the reservoir or in the reservoir और जो हमारे पास टैंक है, ओके, वाटर टैंक or in water tank, so its entrance is changing, then definitely entrance coefficient will also be changed. Okay, so here it vary with respect to its shape. So if you have a question related medical problem, then you will given this diagram, and then you have to remember these values for the coefficients of entrance, either it is 0.51 or 0.04, and here is the alpha in which it is making an angle because this entrance is making an angle with respect to its wall. So here alpha play a very important role because its value will vary with respect. जैसे मैं आपको पिछले एग्जांपल में बता रहा था ना, वहाँ पे अल्फा था. So here if your entrance is with some an angle, then this angle will vary in this equation. So its equation for angle is equal to 0.5 plus 0.3 cos alpha plus 0.2 cos square alpha. So here are just formulas, no need to derivation. Here is the next one in which head loss due to enlargement of the pipe or divergence. So here is the pipe in which the diameter D1 is less as compared to D2. So velocity V1 will be less as compared to V2. So V1 will be larger because there is less. Similarly, at V2 or at the exit or at the downstream side, the pipe is showing divergence. So it means that pipe is increasing its or enlarging its dia. So increasing its dia, then the velocity will reduce. So that's why the velocity head in this section where dia was high, there was a velocity head. There is a high velocity head difference between hydraulic gradient and energy gradient at the upstream side. Similarly, when we observe at downstream side, when dia is increasing, it means that velocity reducing or velocity. If when velocity reduces, it means velocity head will also be reduced. Okay, so because velocity will be square over 2g. So when velocity reduces, it means its total expression will reduce. So that's why here is the velocity head lower as compared to here velocity head is very less at the downstream side as compared to upstream side. So velocity head is reduced because dia is increasing. If you have this if you are facing this problem, then you will use this equation, that is V1 minus V2, velocity at the entrance or velocity at the upstream side minus velocity at the downstream side. It's square divided by 2g. So here is the minor losses about which we are talking about alpha. So alpha its value will be different, and if alpha is different, then value of K will be different. This is the head loss due to enlargement of the pipe. So if you have the value of alpha, then you will use the value of different value of Ke. Okay, जैसे मैं प्रीवियस स्लाइड में आपको बता रहा था कि इफ यू हैव वैल्यू ऑफ अल्फा, मीन के जो वैल्यू ऑफ अल्फा है इट डिपेंड्स अपॉन कोएफिशिएंट ऑफ एंट्रेंस और कोएफिशिएंट ऑफ एनलार्जमेंट. Okay, so its value vary with respect to its angle. So if you know the angle, then you will use that its corresponding value. That is, if the angle if you have if you have known about that the angle of enlargement is 30, then you will use value of ke will be 0.49. Okay, it's ke capital, not lowercase, uppercase ke. Okay, so Hm will be equal to KeV1 minus V2 square over 2G. Its value totally depends upon the theta or angle, that is enlargement angle. So you can use this equation for the calculation of the uh, gradual enlargement of the pipe, having different enlargement angle or enlargement theta. So next one is the head loss due to fitting valves. We also provide valves at different locations and when we are providing fittings, either it is elbow, 45-degree elbow, long radius elbow. So different types of fittings, you will use the value of K. What is L? L is the length of the pipe and D is the dia of the pipe. Okay. So if L by D and type of the fitting, either it is angle or wide open or closed return bend. So you will use the value of K. If you have the value of K, then definitely uh, K and F will be provided and you will get the head loss. Okay, from this you have to use this table. Don't remember these values, but you have provided if you ask about any problem or any numerical problem related to pipe fitting due to its fitting valves. So last one is the head loss due to bends. So here was the valves और मीन के यहाँ पे जो हमारा था यहाँ पे हमने जो वाल्व या जो हम इसमें एल्बो या टी शेप की प्रोवाइड करते हैं उस वजह से जो लॉस क्रिएट होते हैं उसको हम के एफ बोलते हैं. ओके, fitting losses. Kf mean fitting coefficient. Kf fitting coefficient. So last one is the Kb. Kb is the bend. Okay. So what is Kb? Kb is the bend coefficient. Here is also table used for the calculation of value of Kb. So for smooth bend pipes, it is 90 degree. The value of Kb for various values of R, D listed below. So R is the radius. Okay, the curvature bend. Okay, radius of curvature of the band R and the dia of the pipe. R by D is the ratio used for the pipe fittings. So mean के इन जितने भी ये हमारे losses है, you have to obtain the value of Kb from the table, and other one is the velocity head. If you calculate the velocity value and using equation or any operators, so velocimeter or any other devices, so you can use this formula to calculate the minor losses. So there is no derivation related to these minor losses, but here are the some formulas used to calculate different losses produced or created due to different situations.